Okay, here we go. Advent of Code, day 17. Okay, we've got a grid. Let's take a look at the input. Okay. And we're going to input this as just a list and ditch all that parsing stuff. Great, so the next thing we're probably going to want to do is put this into a location place, or a location dictionary. So the pocket dimensions infinite three-dimensional grid, three-dimensional. Oh, three-dimensional grid, okay. State of the pocket dimension also. Your puzzle input. The cubes in this region start with specified active or inactive. Okay. Then proceeds to boot up by executing 6 cycles. Okay, this looks like a life simulation. Whoa, okay. During a cycle, all cubes simultaneously change their state according to the following rules. Small flat region of cubes. Okay, so okay. How many cubes are left in the active state after the 6th cycle? Great, so let's convert this into a dictionary. We're going to call it locks. And then for I comma line in enumerate of L. Well, let's see. So it's going to be R row, and then it's going to be for C comma. All right, let's change these a little bit. So X, Y's, and Z's don't really matter very much, but let's just say X value. Each line is a Y, and then each for X comma C in line, and we're going to say locks of X, Y, 0 is equal to, an active is the hashtag, is equal to, let's see, do we just want booleans? We can probably just do booleans. Is equal to C equals hash. Print locks. Enumerate. Great. True, true, false, true. True, true, false, true. That looks about right. Excellent. That's exactly what we want. So now we need to run this simulation. Okay. Okay, so what I want to first do is add a little util that gives me the adjacent 26. So I already have an adjacent 8 and an adjacent 4, so now we need an adjacent 26. Def adj 26, I think it was. Let me just double check. Yeah, 26 other cubes of lock. And then it's going to be a little bit too annoying to do that. For X plus 1, 2, I think. if okay. That looks like about what we want. Excellent. So now I think that we need to only think about all of the sets that are, okay. For I in, or for a cycle in range, after the 6th cycle. Six, that'll give us 6 cycles. And we can just use the underscore here because we don't actually need it. We're going to say that edge is equal to set for lock in locks edge dot add. That's here for edge set for edge in dot edge 26 of lock edge set dot add edge. Okay, so that gives us all of the things that might be updating, right? So now we've got and then we also want to add all of these. Edge set add lock. Great. So now we've got all the things that we need to think about. So now we just want to say new locks is equal to, well, let's take a look at this. So all simultaneously change their state. If it's active and exactly blah blah blah, it remains active. Oh, we need locks should just be a set of all the active cubes. Doesn't need to be if c equals hash locks.add x, y, 0. Okay. So now we have old locks and new locks. So now we need to let's first figure out which things are going to become active and which things aren't. So now we iterate for lock in locks. We might actually just be able to get away with doing this inside of this other for loop. Yeah, I actually like this. Edge set is a set. So this is all. These are all the things that might be becoming active, even though they're not in the original thing. Okay. Nearby locks. Nearby locks. Nearby locks. We we actually don't need lock anymore. Yeah, I don't think we need that. Okay, for each of the locations, if we need to add all of the nearby locations to nearby locations. Great. And then we need to, for all of these things that are already active, then we need to check to see how many of its neighbors are also active. The cube remains active. Active num if edge in locks, then active plus equals 1. If active nearby equals 2 or active nearby equals 3, then it remains active. Then we say new locks.add of lock. So this is keeping track of all of the old locations, whether or not they stay active. So the next thing we want to do is look at all of the nearby. Lock in. So these are all the ones that may or may not be active. We actually only want the ones that are inactive, because those are the ones that we're trying to look at. Else nearby add edge. So now nearby locations is only things that were inactive, which is exactly what we want. Then we want to say if exactly 3 of its neighbors are active, does the cube become active? Active nearby is 0. For adjacent in of lock, we don't need this. If active equals 3, then new locks.add of lock. And then at the end, we need to say locks is equal to new locks. Print length of locks. 315. A 184, pretty good today. Okay, so... Oh, 4 dimensions? Oh, lovely. Okay, 4-dimensional hypercubes. Okay, for some reason, every integer single cube, if its neighbors, any 80 of the other cubes. Wow, okay. Still apply. Okay, after the... Okay, so we're doing the same thing. We don't have to change much at all. Let's copy paste this. Actually, you know what we're going to do? I think I'm just going to copy paste literally the entire thing. I know that's not good practice, and right now I don't care. And this now it's going to be 0, 0. And then we want to write another util function that's adjacent 80, because that's a thing. 80 for W in range lock. Let's copy this. Lock 3, 3, W, W. Great. Let's just hope that works. And then this is just adjacent 80. This is adjacent 80. And then, is that it? This is line 88 in the util. Oh, forgot to indent this. 1520. Wow, okay. Cool. Huh. This was just the game of life in higher dimensions. I'm gonna clean up this code a little bit because now I'm starting to think like maybe we just want a generic adjacent function, and there's probably a better way of doing this than these dumb nest for loops that I did. But I mean, hey, I'll take top 200. Yeah, this is probably one of my best few days that I've had. So let me think about ways that we can make this cleaner. So the first thing that we can do, obviously, is to change the way, like kind of just move all this stuff into a function that doesn't care how many dimensions there are. And also cleaning up these functions, because I don't want to have to keep writing these kinds of adjacency functions. But there's that clarification of like, oh, do you include diagonals or not between the adjacent 4 and adjacent 8? I'm just surprised that we're continuing to do more of those. But anyway, I think I'll clean this up and you can take a look at that in my GitHub, but I'm not going to do that right now. So have a good night.